Okay, so here we're dealing with more of this pyramid code, and so what you're looking at right here is what I showed you last time. If you notice, I've got some different colors on there, and then some things that I've just kind of left uncolored. Just to kind of touch on real quick what this is. So this geometry that you're seeing here, all these circles and squares and stuff, this is all built out with the foundation being the middle pyramid, the Khafre pyramid, which I have colored in right here in gray, and the circle that's inside of it the same width. So this pyramid, the middle pyramid, the side length is 707.107, which immediately tells you that what they're trying to tell you is to pay attention to the square root of 2, right? Because like I showed you with architecture, different paper sizes and so forth, a lot of these numbers that you're going to see in this stuff actually come out. You'll actually see the same numbers used in these architectural papers like A0, A1, A2, all these types of things. So what we did was we built the geometry. The geometry is built by a combination of various things that we do. So we had this 707 pyramid right here, and then of course to start building the geometry we take a look at the pyramid. Of course, surrounding the pyramid is this circle, which is 1000, which is the next natural progression because they're giving us 707, so obviously they want us to take a look at the square root of 2 on top of that, which gives us an even 1000. So after you do that, and then you start taking a look at, so you add a circle, then you add a square for that circle to be inscribed in, and you keep doing this type of thing over and over. Well, as you build this geometry, and you from time to time may increase the geometry, say a circle and square scenario, by 10%. That's usually what happens. It's usually never any more, never any less. It's usually 10%. If you're not doing that, then you're doing things like calculating the square root of 2, either dividing by or multiplying, and you're building the geometry upwards or downwards. So in the branches of these circles here, so if this is our 707 pyramid, you'll notice that these angles that you see right here, this is the 51.84, and then of course the 38.16. So since these are basically reciprocals of each other, one represents pi over 4, one represents the square root of phi, the gap in between is a 13.68 degree gap. And that is where these little smaller versions of what we're looking at here, which is like the 707, the big pyramid here in the middle, these guys that are in the branches are calculated by the geometry that's built out from this pyramid. Okay, so in a way what this pyramid is doing, especially this Khafre pyramid, the middle pyramid, is it is exposing all kinds of irrational numbers. It is showing us that the irrational numbers that we're all used to seeing can be derived through building out geometry. Okay, so if we take a look at this, the 707, if we get the times the square root of 2, we get the 1000. We bound that with a square. If we turn that square 90 degrees, then we get the value 1414, which is the same value as the square root of 2. And of course, the decimal either needs to be moved or not, but it needs to be understood that the decimal, you shouldn't be paying much attention to that. You should be looking at the number, because you can make anything larger or smaller, right? But the number itself is telling you something. So then we see that as we increase these things by 10% or decrease them, we get this this scenario where you have you're squaring the circle, which squares another set, which squares another set, which is the square root of another, the square root of 2 of another set, and so on and so on. And so all of these irrational numbers pop out, like the square root of 2, the ones in red that you see here. This red one here is the square root of phi, which is actually squaring pi over 2. the number of pi over 2. And then we take a look at these numbers like right here we have the square root of phi, we have 1,000, we have the 1111.111, and that number, of course, if we take that number and turn it 90 degrees, then both points rest on the pi over 2 value, which is squared by the square root of phi value. So all these things have this interrelationship. Okay, so the numbers that I calculated out for you here expose not only the ratios and so forth, but they actually calculate out the certain dimensions of the Great Pyramid. So this tells us something. This tells us that whoever built this stuff either knew about the Great Pyramid and decided to calculate it in with all of their geometry, or it's just random, but I seriously doubt that, because there's way too many calculations that are repeated over and over again, where we see the same values in the Great Pyramid coming out. For example, these ratios, the 151.2, which came out as a result of taking the square root of phi and multiplying it times 0.1188, the ratio of that, which gives us 151.2. And 151.2 times 10 is 1512, which is twice the size of the Great Pyramid's side length, which is 756. So if you notice, all these numbers here that are associated with the Great Pyramid are 1/10 of the value. So if you really want to understand what you're looking at, the circles and squares that are branches inside of here need to be understood that they should be blown up times 10. And I think there's something significant being said there. Okay, so with all that being said, the natural progression is to show you what the Great Pyramid is doing. And so the Great Pyramid is confirming the Middle Pyramid using the same type of calculations. And so although this Middle Pyramid here, the Khafre Pyramid, shows a lot of just general ratios like pi over 2, pi over 4, phi, square root of phi, things like circles with the size of 636. Well, if we take a look at the ratio of that, that's the reciprocal of pi over 2. These types of things, it's just over and over again, this type of stuff. The Great Pyramid is using numbers that are kind of confirming the Middle Pyramid. And also, interestingly, when we calculate things out in the Great Pyramid and we put them in these little branches of these circles, well, notice that what I noticed is that the ratio is slightly different from that perspective than it is with this one. With this one, you calculate these smaller circles using the ratio of 0.1188. As you can see, 1188 is right here, and it's important because it is actually the size of one of the circles. But it turns out that 1188 is actually 10% larger than the 1069.92 value, which is the side length of the Great Pyramid times the square root of 2. Okay, so it's almost like, so if you want to calculate the stuff for the Great Pyramids, you use the ratio of 0.1188. If you want to find the stuff for this pyramid, I'll show you here in just a second what you do. And you can really tell because the numbers start coming out with lots of zeros after the decimal place, and you know you're right on the money when it starts doing stuff like that. And one thing I wanted to show you real quick before we get started, that this is an old drawing, probably over a couple hundred years old, of the Babylonian representation of the universe. If you notice, it's not flat, it is spherical, and it's kind of showing a shell, concentric spheres, that is. And if you notice this pyramid here in the middle, it's not showing simply a triangle for a pyramid. It's showing a rhombus, or an octahedron if you want to consider this thing three-dimensionally. That's important. And these drawings that are several hundred years old They do these like this for a reason. If you notice, these circle traces go all the way around, including the bottom part of this, which is treated as a reflection, but it's actually part of the whole thing. And I'll show you why that's important. And this is the way it looks like with the Great Pyramid as well. It's much easier to treat the Great Pyramid as a rhombus or an octahedron than it is to treat it as just a triangle. It also makes much more sense when you take a look at the ratios associated with it. So this is the same thing as what they're doing right here, and so I'll go into that with you real quick. So here's the Great Pyramid and its ratios down here. The ratio here is 756, and since we're dealing with an irrational number, depending on what they used, it ranges anywhere from 481.09 to 481.25. Okay, so somewhere in that area. But what you're really getting there is you're getting a ratio, because if you take the 756 number, right, and you divide 481 point, I like 091, we get pi over 2, right? And if you notice this 142,827, this is dealing with sevens. If you 1 divided by 7, you can see that's the 142,857 number. So when you see the 1.57142 number, you're dealing with sevenths in there somewhere. So also, if you take 756, so if we take this number right here, and we want the reciprocal of that, and that 6363 number also comes up as circle sizes inside of the geometry that we build when we're taking a look at the pyramids. Okay. The problem with this scenario here is we're only getting half of the picture. It's kind of like looking at half of a circle instead of looking at the whole circle. We're getting kind of half the picture here because we're getting one ratio, we're getting the pi over 2 ratio, but we're missing something crucial, and that is we're missing the square root of phi ratio. So now if we take this and we select the whole thing, you'll notice that we have a 756 by 962,181. 962,181 is the 481 value multiplied times 2, because we have one on top and one on bottom. But the ratio that we get, okay, so if we take the ratio of that, 962,181 divided by 756, now we get the square root of phi. Okay, and if we take that value and we get the reciprocal of it, we get pi over 4. Okay, so you get much more information this way than just the one pi over 2 value, because you're missing out on the phi values when you don't treat it as a rhombus. So another thing about it too is when you're doing stuff with this type of geometry, especially squaring a circle, it's helpful to understand when you're taking a look at these various symbols that they show us, what they may have been used for. So we always wonder why the Great Pyramid was done to where it looks like it has these indented, like it has 8 sides basically, right? Well, if we take this rhombus right here and we take that rhombus and we duplicate it and turn it on its side and we do it like that, then what we've actually got is we've got 2 of them now, but we're showing a lot more information because now we're showing an inner circle and an outer circle. So if I select all of these together, if you'll notice on these corner areas, this would be something we'd be interested in. It does a lot of the same thing that we see when we take those degree markers that you see right here, these lines, and rotate them to the 51.84 degrees or the 38.16 degrees, which is basically the same thing. They're just reciprocals of each other. So when you're squaring the circle with this stuff, for example, so the Great Pyramid dimensions are still here, if you notice, because you have a width of 756 and the height of 481, which is basically half the circle. So if you start at half the circle and work your way up to the top, then this triangle right here represents the Great Pyramid. But we're adding a lot more to that, and that's the reason why you're going to see me probably using this type of a tool more often. So if we take a look here, you might notice that it looks very similar, the lines that you see here on this thing versus what you see on the Great Pyramid, especially if we were to take this thing and turn it, turn it this way. And then as you can see, we have something that looks a lot like the way these things are shaped, right? Because you have two rhombuses crisscrossed on each other. So these values, these parts of the shape that you see right here, that's on the inside, if you see all of these little dotted lines that are selected and being used, it's giving you all kinds of information. It's giving you the outer square, it's giving you the inner one. If we turn it like a diamond, it gives us a lot of information. It gives us the inner square root of 2. This circle that you see that fills this area just perfectly, that's the circle that squares. So that is the circle that is squaring the 756 number, and that's why it is a 594 value. And you can tell because it completely fills just perfectly the inside of this area. So the 756 circle, if we increase the size here to 756, then you can see these areas right here represent the second circle. So if we touch the 594, you can see the dotted line is actually squaring the 756 circle, which is this next one. Then of course we have one more, and that is the 962.181 value. Remember, this is her pyramid right here. Okay, so we're getting a lot of information this way. And so when we add all those circles, it looks something like this. So if we do all these types of things with squaring these circles, and we do them on top of each other, this is the way that it looks. Okay, so we have the width of this outer circle. It's going on the outside of these this rhombus. This circle here that you see on the inside of this outer rhombus is squaring the outer circle. You notice how that's happening? It's squaring this outer circle. And as you move down the line, you have these things inscribing inside each of the next rhombus, and each one of them are actually squaring the next larger circle. So it's a very useful tool in trying to understand that kind of thing. So I highly recommend that if you have not treated it this way, and you can look at these old diagrams from the Babylonian universe, to treat it that way. Alright, so let's take a look real quick, and I'm not going to go into too much detail because you've already seen me go through all this and calculate things out the first time. But I'll show you real quick. So this is the way we did the middle pyramid, and this is the Great Pyramid. These blue lines represent things I can just show you real quick. So that's the 756, that's the side length of the Great Pyramid. That's 481, 116, so you can see that the side length, or the value of 481, is found inside here as you build the geometry downward. So all of these things that you see right here, there's a new value that's being multiplied. So for example, first of all, the largest circle that we see here is actually 1188. And 1188 happens because we have this 1069.2 circle, which is the side length 756 of the Great Pyramid multiplied times the square root of 2. That gives us 1069.2. Now, then we take that value and we take 1069.2 and we multiply that times the inverse of 90%, which is 1 divided by 0.9, and we get 1188. So 1188 is the larger circle here, and these squares that you see and these circles associated with it, like this one here, you can see that the value of it, 141.42, looks familiar, doesn't it? And if you remember all of these circles and squares here, these are all 1/10 the size that they should be. So what I've done here is I've taken all of them that I've calculated out here, I've dragged them over here to the side, and so we'll just take all of those real quick and we will nest them inside of each other, and they look like this. Those are all of the way that they look when they're calculated out, nested inside of each other instead of in the different quadrants. Okay. So then, now, of course, the next thing that we need to do with those things is we need to blow them up 1,000%, which means times 10, and that's going to give us a representation of what this is trying to show us, which has a lot to do with the middle pyramid, you'll see. So we're going to scale this by 1,000%, which is times 10, each one separately, and this is what we get. And I've got a copy right over here, so I'll just go ahead and delete that one. And this is what we get. So the outer circle is 1414, which is square root of 2. It's obvious where that came from. That came from the middle pyramid. We have the 1,000 value, which is the 707 times the square root of 2. And so if we want the 707 number, it's right here. So that's the middle pyramid right there. 810 is a number that is associated with phi. I mean, if you think of 809 being half of 1618, a lot of times what you'll see is phi represented as 1619 sometimes, and I guess its max value would be 162 or something close to that. So you have 707. The rest of this geometry, like the 636.396, well, that's just the reciprocal of pi over 2. 572.760. Well, these are representations also of, if you take a look at a radian, 1 radian is equal to 57.276 degrees. 500, which is half of 1,000. 450, which is half of 900, which is right here. So like I said, the ratios that you use when you calculate things out on this side, when you're using the Great Pyramid to find the values for what you see here in the branches of these circles, is slightly different than the ones that you use in the Middle Pyramid. The one in the Middle Pyramid, you actually use the, for example, if I wanted to get the size of this particular circle and I was calculating inside of the Middle Pyramid, then I would take this circle here that passes through it and I would multiply it times 0.1188, and that would give me my circle, and then from there it's just a matter of getting this, dividing by the square root of 2, and then and one way you can tell whether you're on or not is because the values that you'll get will be very close to an integer, either a .999 or a .0001 or something like that, or it'll be very close to a ratio you're familiar with, like the square root of 2 value or pi over 2 or something, a very familiar number that you're used to. So on the side of the Great Pyramid, since the middle pyramid is actually using the .1188, it turns out that the 1188 value is actually 10% increase on top of the 1069.2, which is the side of the Great Pyramid, 756, multiplied times the square root of 2, which gives you your 1069.2. Take that value, multiply it times 10% with your square, and you get 1188. So as you calculate these values right here, it's a slight difference. Instead of calculating it by .1188, it is calculated using .119, which is also very similar to, let's take a look at radians real quick. So if you remember my 6.84 degrees, so we have a 0.119. So instead of 0.1188, we have kind of like a 0.119381, something similar to that. So also, if you notice these values, they're interchangeable. For example, like this, the gradients here, right? If I were to change this to gradients, and I said this was 7.56, you'll notice that the 1188 value comes up, right? And then you have a 6.8 degrees. So there's a slight difference here in what you multiply these things by. But the values that you get, for example, the 141.422 comes up over here, right? As the square root of 2 value when you blow it up by 10. So over here you have there's the 1000. If that's the 1000, return that. We have a 1414.214, which is the square root of 2 ratio. And then these other values are the same way. This last set that you see here is something interesting that I'm taking a look at right now. And my intuition is telling me that it has something to do with the capstone of the Great Pyramid. And I say that because if I take a look at the old alchemical drawings from people like Robert Flood and people like that, it's a matter of 10 degrees. So if you want to find this, okay, so if you want to find the circumference of a circle, you take its diameter. For example, if this is 1188, and let's go ahead and multiply that. $11.88. Now we're going to divide by 11. Whoops. Divide by 11.454545. That gives us 103.714, which is basically 103.6 is what they're trying to show us here. So that's this number right here, okay? So this represents 10 degrees. So if you multiply that times 36, you get the circumference of the circle, which has the diameter of 1188. So 103.68 times 36, 3732.48, and if I divide that by pi, I should get something close to the 1188. So if I divide that by 0.141882, I get 1188. So without using pi and using that ratio, you can get that. So another way to get these values here would be to take this larger circle and then divide it by 8.4. For whatever reason that's the case. I don't know why that. The 8.4 may have something to do with the size 840 circle that we see, which is part of the sequence of circles that we see when we take a look. 594 is part of that scenario. You'll also see it here in the papers. Like there's an 841 by 1189. You see that, or the 594 by 841. So if you divide this like 1188 by 8.4, let's see what happens. Yeah, 141.42. So basically you get that square root of 2 ratio value again. So this right here is the 103.6, but this is 10 degrees that we're looking at right here. If we move down here at the 962.181 value, this circle is 84, but if we take half of that, then it's 42. And if we take half of the 962.181, then that is 481. So then the 481 may be associated to the 42. And if we see right down here, this blue square is the 481, and this circle that you see right here is 42. And that is because we took 481.091. Well, let's just use the number that it calculated out, 481.116, and we'll divide by 11.4545. And we get 42. And then we get one down here, which is 25.92. That should sound familiar to you guys, which is half of 51.84, and it's also associated with the great year. We have a 33 here. That is half of the 756 value. So anytime you see these numbers, since these represent 10 degrees, if you multiply these times 36, and you just imagine that this circle right here that's on this line, or this circle, if you could just imagine them being right next to each other going all the way around the circle, there's 36 of them. That's what gives you the circumference, because you've got the width of the circle. You have 36 of them together, and that gives you the circumference of the circle. So with 756, that has a circumference of 2376, right? So 66 is a number. So if we take 66 and we multiply that times 36, we get 2376, and we divide that by 3.142, we get 756 basically. So so that's how these are coming about, and I think they have possibly something to do with the capstone part of this thing, but I'm not totally positive yet. But they're definitely very helpful and valuable, because if you want to get the circumference of a circle, this is one way to do it without actually using pi. And anytime I don't have to use pi just for the sake of it, I don't use it unless it's a very consistent pi that I'm seeing over and over again, which the 3.141818182 is what I'm seeing all over the place. And it also seems to be associated with these numbers like 186.624, which has all of these factors associated with the great year, the Platonic year, and all these other numbers like the 144, 108, 216, 864, all these types of numbers are associated with it. In fact, if you divide the 186.624 number by 594, you get the 31418188182 number. So why that's the case, I don't know, but that's the number I find more consistent. So there are other ratios, like I showed you, the 1145 number, and the reciprocals of these types of things that are coming out. So anyway, so there's more pyramid code, and it shows you that the Great Pyramid is confirming the Middle Pyramid. The Middle Pyramid is confirming the Great Pyramid. These are all calculated values. They were not just chosen because of some random weird reason. They are values associated with calculations of ratios and found in the branches of this geometry that's building on top of itself. And my guess is that the whole Giza complex, which I've shown you so far, and shown you diagrams of something that looks very similar to what you're seeing. Like, for example, if we take a look at the Great Pyramid and the Middle Pyramid, they exhibit the same type of thing that we see right here. They are in the same fashion. The only thing that's different is the small pyramid, right, is kind of at a different angle, and it's down here, right? It's in another quadrant. So, but the way that they are showing the distance from each other, the sizes of each other, one's slightly larger than the other. The Great Pyramid is slightly larger than the Middle Pyramid, is exhibiting the same type of thing that we see when we take a look inside of this type of geometry. And so I think the whole complex is doing the same type of thing. So, anyways, more to come. I hope you guys enjoyed that. Pyramid code, and as more comes out, I'll bring it to you guys. Y'all take care, and I'll talk to you soon.